Okay, 3.8 tangent function. So when we start with the unit circle previous unit, then we had a pattern with the sine and pattern with the cosine. So first, when you try to find sine curve, then we looked into quadrantal. So let's say 1, 0, 0, 1. Yeah, this is x-axis and y-axis order pair. And when you look into sine graph, then I look into the y value. So 0 degree, I start from 0, 90 degree 1, 180 degree 0, 270 negative 1, and 360 come back to 0 again. So that's like the pattern you're getting 0, 1, 0, negative 1. So I'm getting something like this. And cosine, I could do the same thing. Cosine, when you just look into quadrantal, then I'm getting 1, 0, negative 1, 0, 1 from 0, 90 degree, 180, 270, 360, or 2 pi. Similar thing may happen for tangent, but from previous unit we learned sine over cosine is a tangent value. Yeah, it comes from SOHCAHTOA. Sine is opposite over hypotenuse, adjacent is, cosine is adjacent over hypotenuse, and tangent, when you put it as opposite over adjacent, then you may put this one as sine over cosine. When you transfer that into x value, y value, when r is equal to 1 from unit circle, you put it at y over x. When you think about change in y, like in algebra, y2 minus y1 over x2 minus x1, change in y over change in x, because you may put it as y over x, then there is a way that you can put this one into slope, change in y value over change in x, which will be same as a slope. So there is a way that we can put this one in slope changing, and the variable we are using for slope is n. So that's why we may put this one into slope. Let me look at first quadrant first and see how sine over cosine, or y over x, is changing in first quadrant. As you can see how sine was changing for entire unit circle value, tangent is changing as well. When you look into first quadrant, so angle theta is increasing from 0 to pi over 2, meaning I am in first quadrant. So 0 is here, and first pi over 2 is right here. And angles keep changing, so you have infinitely many tangent values from here, because angles keep changing from 0 to 90 degrees. When you look at first tangent of 0 degree or 0 radian, then I want to do sine 0 over cosine 0, meaning I can put this one in sine 0 is 0, and cosine 0 is 1, so 0 over 1, which will start with the 0. So tangent 0 is 0. I'm going to approximate this one. Let's say angle theta is keep increasing. So it's 0 degree, let's say 30 degree, 45 degree, and 60 degree, and 90 degree, or getting close to 90 degree. Angle thetas keep changing. So when I ask you to find tangent of 30 degree, which is same as pi over 6, then I want to do sine 30 over cosine 30. When you think about this value, then I'm getting radical 3 over 2 for 30 degree cosine, and y value sine is 1 over 2. So when you put it in sine over cosine, then I want to put it at 1 over 2, divide that by radical 3 over 2. Yeah. If you simplify this, then I'm getting 1 over radical 3. 1 over radical 3, okay? When you punch that into the calculator, then you're getting approximation, 0.571. I know we didn't put this one in the calculator, but then I'll show you how this value is changing. How about 45 degree family? 45 degree, radical 2 over 2, comma radical 2 over 2. So when you find tangent of 45, then radical 2 over 2 repeats from numerator to denominator, so I'm getting 1. And let's move on to 60 degree. I know this is not 60, but let me approximate this value in 60. Then I'm getting x value 1 over 2, y value radical 3 over 2. When you put this one in tangent of 60, then you're going to get radical 3 over 2 divided by 1 over 2. And when you simplify, I'm getting radical 3 in the numerator. And when you put this one in calculator, I'm getting 1.7 something. This last one is a little bit less than 90 degrees. So let's say this is 89 degree. Getting really close to 0.1. 0.1 is a order pair for pi over 2 or 90 degree. When you're getting really close to 0 for, let's say, 89 point, then can I just do 0.1? Getting, yeah, move just a little bit, 0.1. And then you go up and getting really close to 1, how about 0.99? Yeah. It's not 90, but really close to 90. So 0.1 and 0.99, okay? Compared to 0.1. Yeah, you move just a little bit to the right, and then you go up and really close to 1, 0.99. Then I ask you to find tangent of this angle, tangent 89. Then I want to do y value divided by x value, 0.99 divided by 0.1. When you put this one into the calculator, then I'm getting 9.9. If I get really close to this one, let's say I'm getting tangent of 89.99999, then what you will see is this value is getting really close to 1, which is 0. More nines. And when you do 0.0000, more zeros than 1, then this number is getting close to infinity. Or think about this. What is a tangent 90? Tangent pi over 2. I want to do 1 over 0. 1 over 0 is undefined. Yeah. What I'm trying to do is I'm trying to show you tangent curve. Looks like something like this. So you see vertical tangent because we got undefined. Look at this one. This is only for quadrant 1, between 0 to pi over 2, right? So you start from 0, and your numbers keep getting bigger. And eventually getting asymptote. What you will see is when you're at 0, I got 0. When we are at 45 degree or pi over 4, I got 1. For 30 degree, I got 0.57 somewhere here. When you get pi over 2, we are getting undefined, so you are getting asymptote, vertical asymptote. When I try 60 degree, I got 1.7 something. 60 degree somewhere here, 1.7 something. You see how this is increasing here? Actually, first quadrant only covers from here to here. From 0 to pi over 2. I only did this guy. Right here. 0, 0.57, 1, 1.7, and then higher number. When angle theta was at 0, I got 0. But as theta approaches to pi over 2, then you're going to see the slope gets steeper and steeper, more positive. When theta is equal to pi over 2, then slope of a vertical line is undefined. From here, I want you to remember two things. Tangent 0 is a 0. When you come up to tangent 45 degree, then you got 1. And then when you get tangent 90 degree, or pi over 2, then I'm getting undefined. When you think about putting these together, then what you will see is, when you make the tangent graph, let's say I want to start from 0 here, pi over 4 here, and pi over 2 here. We are doing similar thing that we were doing for sine and cosine, but then a little bit different. Say tangent 0 is 0. Tangent pi over 4, 45 degree is 1. And you know you have values in between, right? It was increasing. And then tangent pi over, this is tangent graph. Tangent pi over 2 gives us undefined, so undefined here. Yeah. What you will see is this will go up like this. Yeah. We need the same thing for the negative side. Yeah, you will see it, but then when you think about doing tangent of negative pi over 4, this is same as tangent of 7 pi over 4, then you are going to get negative 1. And then when you do same thing for negative pi over 2, then you have another asymptote. So what you will see is tangent graph looks like something like this. Something like this. Go back to sine. Sine, I tell you to do 0, 1, 0, negative 1, 0 for the pattern. Something like this. For cosine, I was doing 1, 0, negative 1, 0, 1, so I'm getting something like this for cosine. Tangent, I want you to think about tangent 0 is 0. And 45, I'm getting 1, and then you're getting the asymptote. And left side, I'm getting negative 1 and the asymptote. So what you will see is, when you make the tangent graph like this, then 0, 1 meaning go up 1 and write 1 in between here, and then negative 1. So you're getting negative 1, 0, and the 1. And in between these two asymptotes, I am getting something like this. This is a shape of tangent graph. Yeah, so negative 1, 0, and the 1 for the pattern. Let me look at the bottom part of page 1. Yes. When you get undefined, okay, you can put this one in limit notation. You are going to see function tangent theta. Limit notation means we are approaching to. Theta, input is approaching to pi over 2. And I'm not sure if you guys see it here, but then you see small, number or sign right there. You have a, minus sign right there. This is the meaning of this is we are approaching pi over 2 from the left side or from the negative side. Negative side means the left side. So could you copy this down? This meaning the meaning of this is we are approaching from the left side. Yeah, left side of pi over 2. I'm approaching pi over 2 from the left. Because for this one, I was at first quadrant, 0 to pi over 2. So I'm approaching pi over 2 from the left side for tangent. I am getting infinity. Remember, I was doing like 9.9 over 0.1. But 999, more zeros than the 1. Yeah, infinity. Questions? Let me move on to second quadrant. So pi over 2 to pi, second quadrant, meaning these are all second quadrant. You see, yeah, these numbers are keep changing, right? Yeah, but then when you remember this, I think, yeah, you will see the pattern of tangent graph. From here, I want you to remember one thing. Tangent theta is negative when you're in quadrant 2. Yeah. From here, I just want you to remember this. Tangent theta is less than 0, negative, in quadrant 2. Why? Think about this order pair. When you're in second quadrant, then cosine is negative. Cosine is negative because you travel left and you go up by, right? Up by this much. So travel left means x value negative. When you're doing tangent, tangent is a sine over cosine. For quadrant 2, I'm always getting positive from numerator and negative from denominator. That's why it's negative. Then what happened to when you're in third quadrant? This one covers in Q3, quadrant 3. Here, quadrant 3. Again, values are keep changing, yeah, by looking into unit circle, but then, yeah, I don't want to go over unit circle values again. You will see it will keep changing by doing tangent, theta, -1, 0, and the 1, and asymptote and asymptote, right? That's what you're going to see a pattern. But then when you're in third quadrant, this one's negative, comma, negative, negative, comma, negative for cosine and sine. So when I ask you to do tangent theta in quadrant 3, then what you will see is negative divided by negative, which gives you positive. So tangent theta is greater than 0 in quadrant 3. Let me look at this one in quadrant 3. Where are we in quadrant? Here. Quadrant 3 is in between pi to 3 pi over 2. Where's pi? Pi is here. 2 or pi to 3 pi over 2. 3 pi over 2 is here. This one covers in quadrant 3. Can I go back to this? Okay, tangent 0 is a 0. So I start here. So here to here covers or comes from quadrant 1. Do you see positive values? Pi over 2 to pi means here to here is in quadrant 2. Quadrant 2 tangent values are negative, you see negative. And quadrant 3, negative divided by negative gives me positive. And then quadrant 4, when you do quadrant 4, Q4, then I'm going to be in between 3 pi over 2 to 2 pi. You see how these are negative? Because when you are in fourth quadrant, then this one is positive, comma, negative, meaning when you do sine over cosine, then I'm getting negative over positive, so negative. So first quadrant, second quadrant, third quadrant, and the fourth quadrant. values keep changing. Positive, negative, right? Yeah. But then we are not putting those values every single time. I just want you to remember. Tangent graph will change with the pattern with the -1, 0, and the 1. Okay? Tangent 0 is 0, and then this is the first tick mark. Next tick mark, you have an asymptote. This one should be negative pi over 4, and then when you do the next one, then you have the asymptote. Let me show you here. Tangent 0 is a 0. Tangent pi over 4 is 1. Tangent negative pi over 4 is, so I'm doing -1, 0, and the 1. Between these three tick mark. When you go one more tick mark, then here should be asymptote. And when you go one more tick mark to the left from -1, then you got asymptote. Does that make sense? And then pattern stays the same. When I ask you to find the period for tangent, yeah, this is a parent function for tangent. This is negative pi over 2, and this is positive pi over 2. Think about this. Let's see, here's the center. So when you think about period of this one, then from 0 to asymptote, first asymptote on the left side is negative pi over 2. From 0, first asymptote, vertical asymptote on the right side is positive pi over 2. So when you try to find the difference between these two, actually this one is pi over 2 and pi over 2. So it becomes 2 pi over 2, which is pi. Period is pi. Yeah, I forgot to go over key concept. When we graph the tangent function, whenever you're getting y-axis quadrantal, pi over 2, 3 pi over 2, or 5 pi over 2, 7 pi over 2, then you are going to see vertical asymptote. Vertical asymptote. And from algebra 1 and 2, we learned when you have a vertical asymptote, slope is undefined. And I'm actually getting undefined from 1 over 0 or -1, 0 from y-axis, pi over 2 or 3 pi over 2. That's where we are getting the asymptote. You see here, pi over 2 asymptote, 3 pi over 2 asymptote. Yeah, from unit 5 we are doing similar, we were doing sine and cosine, now this is tangent. A value, we don't call this one with amplitude anymore. Amplitude only works for sine and cosine. But then we are still using A value, represent vertical dilation. C value, horizontal translation, right or left. P value going up and down, vertical translation. Only difference from sine or cosine was period. Yeah. For sine and cosine, we are doing 2 pi over b to find period. Tangent is 1 pi over b. Yeah. 1 pi over b, not 2 pi over b. If you ask me why, think about this. I'm finishing this cycle by looking into unit circle value. So when you are doing 0, 1, 0, -1, and 0, you need entire circle to finish one cycle. So for sine, you are getting 2 pi from parent function. I'm talking about period. When you think about tangent, I'm starting from here, 0. This is 1, and the asymptote, and then -1. And then 0 again. So actually from half of a circle I finished one cycle already, which means I'm doing -1, 0, 1 asymptote within pi. or just remember, sine cosine period formula is 2 pi over b, tangent 1 pi over b.